Hi guys, welcome to this class. I hope you've been well. All right, so today we have this question. It's a radical question. Radical in the sense that we have this signs there are called radical signs. Follow me as we solve it together. Let me write the question. So we have the root of 2 all over x plus the square root of 2 is equal to 1 all over x minus the square root of 2. All right. So what do we do first? I can do this in two ways. Yeah. We can either find the LCM of these two, right? They do or obviously look like they are a difference of 2 squares, right? And we can do that, and we can cross multiply, right? So I would love that we just cross multiply in this case. So let's cross multiply. So now I have something like this: the root of 2 into x. This is x, please. Minus the square root of 2 is equal to 1 into x plus the square root of 2. Okay. So now our duty is to open the brackets, right? Simple algebra. So let's open the bracket. The square root of 2 multiplied by x. That's just like saying, let's represent that with something. Let's say we have a into x minus a, right? So we'll say a times x, that will be ax, or maybe xa, whatever, and then a squared, right? So in this case, we have x root 2 minus, the question is, what is root 2 multiplied by root 2? Root 2 multiplied by root 2 is equal to 2. How do I know this, right? So let's say this is a perfect square. What's a perfect square? A perfect square is a number whose square root we can easily find, right? The square root is also a whole number, right? So a perfect square is a number like 4, 9, 25, right? 16. Those are perfect squares. So in this case, let's say we have the square root of 9 multiplied by the square root of 9, right? So this will give us 3 multiplied by 3. So we have 9. So we can also prove this with indices though. Let's do that. Let's do that somewhere here. Let's do that. So we have the square root of a plus the square root of a. This gives us, we can write this in index form by saying a raised to the power 1 over 2. Did I say plus here now? Sorry. We are multiplying, not adding. So a raised to the power 1 over 2 multiplied by a raised to the power 1 over 2, right? By indices, when you multiply, what do? We add their index. So we now have a raised to the power 1 over 2 plus 1 over 2. And this gives us a raised to the power 1, yeah, which is a. So invariably, what I'm trying to say is the square root of 2 multiplied by the square root of 2 will give you 2. Okay? So we have x into root 2 minus 2 is equal to 1 multiplied by anything, it's the same here. So is equal to x plus root 2. X into root 2 minus 2 is equal to x plus root 2. Okay, so this is where we are at right now. This is the equation we have. What do we do next? Let's collect like terms. Right? So we're bringing this to this side, or we're bringing this to this end. So now we are going to have x root 2 minus x. When this comes to this end, it becomes minus x is equal to root 2 plus 2. Negative 2 coming to this end become plus 2, right? So what do we do here? Let's factorize. We're going to factorize x. We're looking for x, right? So we're going to try as much as possible to isolate x. So now we're going to say x into root 2 minus 1 is equal to root 2 plus 2. Okay? Now we can isolate x. What do we do next? So divide both sides by root 2 minus 1. We're going to have x into root 2 minus 1 all over root 2 minus 1 is equal to root 2 plus 2 all over root 2 minus 1. Okay, so yeah, all of this is going to cancel all of this out. Now x is equal to root 2 plus 2 all over root 2 minus 1. And what do we do next? It's not mathematically correct for us to leave our answer this way, so we do what we call rationalization. In short, we call it we rationalize. What do we mean by rationalization? Rationalization simply means we have to clear out all the radicals in the denominator. Okay, we have to clear out all the radicals in the denominator. And how do we do that? We're going to multiply the denominator and the numerator by the conjugate of the denominator. So question, what is the conjugate of the denominator? So the conjugate of this, the conjugate of root 2 minus 1 will be root 2 plus 1. Okay, simply just change, what we always do there is change the sign, and that's the conjugate. So we're going to have to multiply this. So now x will be equal to the square root of 2 all over the square root of 2 minus 1 multiplied by the square root of 2 plus 1, and same thing there. So we're going to do this the way we do our normal algebra. Is, where we have a plus b into a minus b. What do? We say a multiplied by a, that's a squared. A multiplied by negative b, that's negative ab. Then this, right, plus ab. Then that minus, right? And then we continue all of this to get our answer. So we're going to do the same here. So we're saying root 2 multiplied by root 2. That will give us 2. Root 2 multiplied by 1. That will give us root 2. Anything multiplied by 1 is the same thing, right? Root 2 multiplied by 2. That will give you plus 2 root 2. And then 2 times 1. Basically, that's 2 all over root 2 multiplied by root 2. That will give us 2 also. Root 2 multiplied by 1, that's plus root 2. Negative 1 multiplied by root 2, that's negative root 2. Negative 1 times plus 1, that's minus 1. Right? So this way, it's going to give us 2 plus 2, that's 4. Root 2 plus 2 root 2 is like saying x plus 2x. So in this case, x is the root 2, right? This will give us 3x. Okay? So, yeah. This is saying, so 2 plus 2 root 2 is going to give us 3 root 2 all over 2. These two will cancel out to each other. 2 minus 1. So we're going to get 4 plus 3 root 2 all over 1, which is 4 plus 3 root 2. Therefore, x is equal to 4 plus 3 root 2. I hope you guys understood that. Thank you very much for coming to this class. I hope to see you in other classes. To enjoy the rest of your day. Bye-bye.